5.3, let's go. So domain and range. Just know the domain is basically all the values that are possible for the x, right? So going the left and right on a graph. And y is all the possible values, or the range is for all the possible values of y, right? So how far up or down it can go on the graph, or so yeah. So whenever asking your domain, it's asking you everything, for the x values and y for range, right? So that's all it says really in here. And just it also says input value. So x is going to be your input because remember x is your independent variable. So that means you get that independent variable input, and whatever that is, the output, what it spits out, is the dependent variable, the y, right? So yeah, so just know that input is the x values, which is also the set of domain values, and y is the output, which is the range values that we're looking at, right? And there's in this section, all we're looking at is different ways to express domain and range. So different ways to write it, different ways to communicate what the domain and range is, right? So the first set here is writing as a list. So super simple. List, you can just put it as well, list is over here, but say you have a set of pairs. So you have 3, 7, 4, 8 pairs, 5, 9, and I guess remember these are spots on a graph, or positions, I guess. So when x is 3, y is 7. X is always the first number. When x is 4, y is 8. When x is 5, y is 9. So what is the domain and range? So writing as a list. So just have to write, I don't know what this is really called, the bracket. What's that? Squiggly bracket, right? So just like that. You find it on your keyboard too if you want to know how it exactly looks like. So you get your squiggly brackets and writing the domain, which is all the x values. So 3, comma, 4, comma, 5. So just writing it as a list. Same thing with the range, squiggly brackets, and the second value, 7, comma, 8, comma, 9. Right? And that's all you're doing in pretty much both of these examples. Just note that if you have it twice, right, you don't need to write it twice. So here you have the squiggly bracket 11. So the 11 is the only position for the range, right? So you don't have to repeat the number. You can also read it off of a table, same sort of thing, x values, y values, and they have it written down there. So pretty straightforward. Okay. The other way to express domain and range is looking at, oh, we're not there. I was going to talk about interval notation, but here we're talking about in words, right? So say you have a number line, right? So these are the number lines, and we do the other way around in the thing example 4. So this is your number line, and you've probably seen number lines, if not in grade or 9, for sure you've seen it in elementary school. So the dark line represents our basically our values that we're looking at here. So just note that it doesn't, if it's a circle is filled in here, like how the 3 is filled in, we include that number. If it's not filled in here, it's just like a non-colored in circle, that means we're not including it. So so it doesn't really say what if this is like the domain or range, but whatever this value is, so we're saying that the values are greater than -4, so greater than, not equal to, so greater than -4, all the way up to 3, including 3. So greater than -4, but less than or equal to 3 because it's colored in. So let's look at this example. So here it's going to be, it just says greater than 3, but it should also be greater than or equal to 3, right? Because it's filled in. So this is greater than or equal to 3, right? And it's just greater than because at the end of the line, you can see that there's an arrow here. So the arrow just means it continues forever in that direction, right? Where these ones, they end with these circles, meaning that they stop at those points, right? So example 3, describe the set of numbers of each of the following using interval notation. So when you're looking at interval notation, we're going to look at, so this is words. This is interval notation just like when we're using greater than or less than or greater than and equal to or less than equal to signs. So just a quick review. On the left here says less than or equal to is you have the little arrow or the Pac-Man. So the open mouth of the Pac-Man is the greater than side. On the left here on this side where the point is the less than side. On the right here is the greater than side, right? So or you can write it the other way around, but now we just flip it around. So this is greater than or equal to, so meaning that this number on the left is going to be greater than or equal to the number on the right here, right? So whatever's the numbers on the open mouth is a greater than sign, and if you have the line underneath is equal to. So let's look at this a couple of examples. Example 3. So here you can see that the 2 is filled in, so we're including the 2, and it's going less than 2, right? So here I guess we're using the variable x. It doesn't really say if it's like domain, but you could say we just use it x. So whatever the number is, it's going to be less than or equal to 2. So you can see here we have x less than or equal to 2. Okay, so here we are going to have to, there's 2 sets of lines here, right? So we know that we're going to have 2 interval notations, one for this section and one for this. So let's do this one first. So you know that x is going to be here, is going to be equal to or less than -1. So that's what they have. X is less than or equal to -1. And on here, you can say x is greater than 4, not including 4 because it's not filled in here. X is greater than 4, so comma. There you go. Okay. Example 4, represent the set of notations indicated using a number line. Okay, so now they're going to give us a set of numbers, and we're going to draw the number line. Okay, so all numbers less than 5 but greater than or equal to 0. Okay, so here we know it's going to be all numbers less than -5. So we got the not filled in because we're not including 5, and it's going all the way to 0. But it says greater than or equal to 0. So here it stops. It doesn't keep going, but it stops at 0, and we include 0 because it says or equal to. So yeah, simple. Here, this might be some kind of convention here. I'm saying it only in grade 10 because you might not see this too often, but we'll use it for this section. So when there's a curve bracket, we're not including this number, right? And when there's a closed bracket, we are including that number there, okay? So here, you can see that this value is not filled in because we're not including the -4 since it's a curved bracket, and it's going all the way up to 7, and we got it filled in, okay? So I guess you'll see this in this chapter, but you don't really see these types of questions where you have a set of pairs and you draw it like that, and yeah, so you don't see this too often. Okay, so example 5, determine the domain and range of each of the following use set notation. Okay, so first I was looking at set notation. We'll look at this one that's done so we can kind of explain set notation. So again, set notation, we have these squiggly brackets on either side of, well, I'll explain what's inside. But say if we're looking at the domain, right? So we're going to have x here and a big long line here, and then whatever the x values are. So that's kind of the set notation. You do squiggly lines outside and inside. If you're looking at domain, you have the x. If you have looking at range, you put the y, and you put a big line down here, and then you put all this, whatever the domain and range is in there. So we wrote that down, and then what are the x values? You can see that there are discrete points here on if you're looking at blank sheet, right? And then these are just to help figure out where they are. So these discrete points, now we're just going to look at each point and see where the x is. So look at this point, so it's 1, 2, so x is 2. This point is x is 1, right? The point on the left here, 1 to the left, is going to be -1, and then there's 2 points on 1, 2, -2. So we're just putting all the x values of these points, right? And you don't have to repeat them if they come twice. Same thing for the y. So again, set notation, these little curvy brackets, and then this solid line. And now we just go up and down to see where the points are. So there's a 1 point here at 1. So we have the 1 here. There's 3 points at the 2 spot, 1, 2, right? So there's 2. And there's also a point down here, so -1 on the y. So -1. Okay. So you do the same thing here, but now they're not discrete points. You can see that it's a continuous graph here, or this oval here, ellipse. And what you're going to do here, again, x. So what are the x values? Like, again, we're asking what the domain is. Like, how far to the left does it go to, and how far to the right does it go to? So the x value, it goes to 0 and touches 0. So we include it, and then to the left, and all the way to the right, it goes all the way to 4, and it includes a 4. So when you have the set notation, same format that we did before. So x is going to be greater than or equal to 0 and less than or equal to 4. So you can see it fits in that space. So y is going to be the same thing, but we're going up and down now. So you set it up the same way, the set notation format, and then you can see y goes all the way down to the 0 point on the y, and it goes all the way up to the 2 point on y. So same sort of thing, but 0 to 2. Okay. I'm just looking at all these. So you can read this example. It's pretty much the same. Just notice that the circle's not filled in, so you don't count it. What would be a good example to go over here? So I don't make these videos too long. Okay, let's just do the last two here. Okay, we'll do E and F, and you can look at C and D to see how it's done. Okay, yeah, so this one will be kind of good to do because it says it's R, so we'll talk about that. Okay. Okay, so we have this parabola shape going upwards. And notice before we even start doing this stuff, notice that the parabola goes on forever because it has these arrows, right? So we're going to do the x value. So how far does it go to left and right? It pretty much goes on forever in the left and right direction because it's going to the left forever. It's going to keep getting wider and wider and wider on left and right direction. So here, what's the domain? So if it goes on forever in both directions, all you write is x, and then you have this little e looking sign, which is not e, it's like a Greek letter. I think it's epsilon, I think. But this element here, I wrote element here, it represents whatever's in here, which is all real numbers. So if you're going to write all real numbers, you just write the x, this little epsilon sign, and then this r looking symbol as well, which is, it's not really an r, but all real numbers, meaning that it's going to be everything, right? So, and then the y value, and you can see y goes on forever, but only at the -1 point and higher, right? So you can see that the range, the set notation, y is greater than or equal to -1. So -1 and everything above. So, and you can see on the left here, we'll go to the D anyways, we'll go back, we'll do this example, but when you're doing it, you can see that now it's going to the right forever, left forever, down forever, up and forever. So that's why the domain and range is all real numbers for both examples. Okay, and let's do F here as well. So F, you can see that this is a discrete graph that we talked about before. The points are not connected. It's also increasing exponentially as well. So you can see the slope is it's not a linear relation. It's just increasing really at more of a rapid rate. So again, now you're just going to plot the points. So 0, 1, 2, 3, 4 for x, and that's what they have. And then for y, it's like 0. Oh, and notice that I was going to say 0 and then 0.5, but it's not really 0.5 because 2 squares is 4. So that means this square has to be 2, and then halfway has to be 1. So this is going to be 1, and there's 1 at 4. And then this looks like 9, I guess. Yeah, 9, 16. And you can see that this relation is an exponential relation here, actually. So the formula would look like y equals x squared, right? And yeah. All right, so 2 more examples, and then we'll finish this section off. Example 6, a relation is given by the formula y equals 3.5 x plus 5. So here is our equation, and when you get equations like this, if they ask you what's the x or what's the y at certain points, you just plug in the values. That's all you're doing. So if the domain of the relation is -10 to 10, what is a range? Okay, so they're saying that the domain, the furthest it goes to the left is -10, and the furthest it goes to the right is 10, right? And now you just plug those two numbers in 2 separate equations. So we'll do the -10 one first here, and then just plug -10 and solve for y. The y is going to be -30. Then do the +10, the domain all the way to the right, plug it in, and you get 40 for y when you solve it. So the range is going to be between -30 and 40. And that's what we got here. Okay. Last example. A relation consists of integers where the second number is 1 more than the square of the first number. Okay, so this is where you got to kind of read a word equation and put it into like a formula, right? Write 5 ordered pairs for this relation. So before you even do this section right here, we're going to have to get this equation. So a relation of integers where the second number is 1 more than the square of the first number. So if you put y, right, as the second number here, so y is equal to x squared, right? And I know to put y is equal to x squared because remember y is the dependent variable, x is the independent. So we're going to put x here because whatever x is, the square of that equals y. So y is dependent on the x, so y equals x squared. Is 1 more than the square of the first number. Oh yeah, so it's 1 more. So it says it's 1 more than the square. So it's also going to be y equals x squared plus 1. There should be a 1 here too. Okay. And then after that, it says write 5 ordered pairs for this relation. And these ordered pairs, you plug in any number. So when x is 1, what is y? You plug it in. 1 squared plus 1 is 2. When x is 2, 2 squared is 4 plus 1 is 5, right? And then when x is 0, 0 squared is 0 plus 1 is 1, right? So you just do that. You just pick a bunch of numbers, and there you go. And you plug it into the formula. Okay, hopefully that made sense. We got done 15 minutes. I think the last video is 15 minutes, and then hopefully the next one will be under 15 minutes. So we'll try to keep the notes under an hour today. Okay, let's move on. 5.4 next.